Her dad, who I met, who passed away, he, Latvian, he came to this country. Estonian, yep. I was just checking, see if, is there a rivalry?
No, well, just another small country.
Yeah, go Baltic states, yeah. Estonian who came to this country because of technology. You are a American citizen because of that. What was the genesis of him coming here, and how does that shape the kind of crazy, visionary, very successful guy you are?
Well, it's funny, I didn't expect that, but my dad has always been my hero. In fact, when I wrote a Stanford essay to get in undergrad, one of the questions was, who are your heroes? And I said Steve Jobs and my dad, and still the case today. Yeah, he convinced Motorola in 1966 that he knew something about photolithography because he had done a lot in photography, and those sound pretty similar, but putting glib things aside, he switched from Bell Northern Research in Canada to Motorola in the early days of the chip industry in '66, and that's why I'm a US citizen. I was actually conceived in Canada and born in the USA. And my whole life growing up, he basically ran fabs, some of the largest memory production plants in the world, from Malaysia to Ireland to Texas. And yeah, that sort of inspired me to get into electrical engineering. There was like no doubt that's what I wanted to study when I first came here to Stanford.
So my buddy Omar, who was president of the class at Stuyvesant, was, I think, in your dorm at Stanford, and he's told me some great stories. I think mixed tapes were involved. The tapes, for those millennials, those are linear things that wrap. When did you get into AI? Were you clueless on AI in college, and you got the memo like a week ago? Like what's your trajectory on AI? Have you been in on it?
No and yes. I was fascinated by the first time exposure. There wasn't like a whole course curricula like there is now at Stanford. Some of the most popular classes are the AI classes. That didn't exist back in the 80s when I was here as an undergrad. But in 1989, I took a class on parallel distributed processing by Remmelhard. It was an early neural network class. And I started a PhD in electrical engineering to specifically focus on neural networks, which is today's architecture for AI, and how to exploit orthogonal degrees of parallelism in custom silicon. In other words, how can we use parallel computing, which we would now think of as GPUs, to basically enhance and accelerate what were the early fledgling attempts at AI back then.
So that was a long time ago. For those who don't know, that was the century before.
Yeah, last
There's
century.
been an AI winter as these things happen. I don't know if there's going to be an AI winter anytime soon, but how were you affected by the AI winter? Did you put AI on a back shelf?
Absolutely did.
And said, I'm going to do space things?
That came a lot later.
And then if AI did become relevant to you, what was the wake up in the middle of the night moment that made that happen?
Yeah, I remember this vividly because there was a long drought. There were a few people that stayed at it, if you will, famous neural network researchers in academia, but it was tough to get funding. It was tough to make progress. People thought, this is just going to work. And I had a fundamental belief that this is the architecture of the mind. This is how we recapitulate our biology, and it is an inevitable future vector of AI development, but it wasn't working yet. 2012, everything changed. There's an ImageNet competition that Fei-Fei Li here at Stanford has been holding that basically is an open competition. Who can best recognize patterns in a bunch of arbitrary images? And in 2012, a guy with 2 GPUs did this thing called AlexNet, and just blew the doors off the #2 contender. In fact, it was such a dominating win that all of these competing approaches for image recognition were put aside, and the convolutional neural net became the beacon from that point on for this kind of task. And that, to me, was fascinating, because it's harking back to my studies that I put aside from the 80s. And it also struck me as quite interesting that the NVIDIA GPU, just 2 of them, had done something so powerful. I had been, through a friend, keeping a track on the use of GPUs for something other than playing games, which, by the way, was a radical concept before 2012, right? That was not done. But I knew the guy who had bought a bunch of them at Fry's, built a home supercomputer, and was doing neuronal modeling of all things, a scientific kind of project, using them. So I had this prepared mind, if you will, to say, wow, the computer architecture being more fine-grained, being more like the brain, might actually be the future of AI. And when these GPUs did it, I was like, whoa. From that point on, started evangelizing AI. In 2013, I sort of predicted in a debate with other VCs that AI would be the most important tech trend for the next 10 years, so bringing us to today, which was heavily debated at the time. No VCs said AI was an investment sector. Right? That wasn't on anyone's website in 2013. In any case, that was the wake-up call for me.
So do you know who Ada Lovelace is?
Yeah, first software.
Have you met her?
No, she's a long time ago. I'm not that old.
So I love, Steve, that you have extrapolated not just forward, but backwards. And Moore's law is something that a lot of people know. Whole industries have kind of been built around anticipating it. But you weren't satisfied with just being handed a graph by a consultant. You said, let me do my own analysis. And this is your life. We've brought your analysis. Can we throw this slide up that Steve made? And can you tell us, what are we looking at? Why is it interesting? And what should we take away from this to inform us on how to make the most of our finite time on this planet?
Yeah, so first of all, let me just ask a question, give people a chance to stretch. How many people have seen this graph or Ray Kurzweil's earlier versions? And if you could hold your hands for a sec so I can give a rough sense of the percentage of the crowd.
It's a pretty sophisticated audience.
Yeah, I'd say it's the highest I've ever seen, maybe about 30%. I show it, or try to, in every presentation I ever give. I think it's the most important thing ever graphed. So I give the credit to Ray Kurzweil. He first published this in 1999. He used it to predict when a computer would beat humans at chess. He used it to predict just about everything that's come true. He predicts AGI, by the way, will come.
Oh, you got to get Ada Lovelace on here. She's not.
I know. Well, there was a software side. This is just hardware architectures. But and Babbage's machine. But we'll talk about Babbage's machine, the analytical engine, if you'd like. So what are we looking at here for two-thirds of the room who don't know? So first off, notice the y-axis is a logarithmic scale. Every tick mark is 100x, 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 and it's showing price performance, basically how much compute can a dollar buy. This abstraction is what matters, is what customers buy. They don't buy transistors by count, the way Jordan Moore saw it. He saw a refraction of this longer-term trend. In fact, it has nothing to do with integrated circuits. The gray bars vertically show different technology epochs, everything from the vacuum tube computer that predicted Eisenhower's win in '56 to the relay-based computer that was in the movie Imitation Game that cracked the Nazi Enigma code. And no one knew they were on a curve back in the early days, right? It took a while before Ray Kurzweil, going back in time, realized, wait a second, a straight line on a graph like this is an exponential. This is actually like a double exponential that's held for 130 years. That's mind-bending, right? The Great Depression had no long-term impact on this. Economic recessions had no impact on this. In fact, we're looking over this time span at 1,000 billion X improvement in price performance of computing. That's what's driving AI today. There's this great essay on sort of the bitter lesson. A lot of things can be solved with just more compute if you have the right architecture, the brain being an example. If you don't have as many neurons, you end up with a nematode, right? The number of nodes matters. The number of compute elements matters to intelligence. And so there's a whole bunch of economic and business implications from this, almost cosmological. Why is this happening? If it has nothing to do with Intel, it has nothing to do with semiconductors or even integrated circuits. But the investment bet we'd make is it's going to continue for another 5, 10, 15, maybe 20 years, maybe 100 years. And what happens next? And that's what gives people like Kurzweil predictive power on when AGI will come, when a computer that you could buy for $1,000 will have more capacity than a human brain, or all human brains on Earth combined. And those are predictable propositions if you believe in this curve. So that's why I think it's so important. And it drove, what you'll see in green, this other point, is that there was a baton handed off from Intel to NVIDIA, right, over a decade ago, where Intel has been no longer relevant to the future of AI compute. I mean, completely irrelevant, right, as people in this industry now know. 10 years ago, I'm not saying that, it was less obvious than it is today. But the future is going to move to ASICs, custom chips for this. It's already happening with a number of different products, both analog and digital, and they outperform the GPUs of the today. There's always a slowness in adoption when you have something new, but basically the TPUs within Google, Amazon's building custom chips, OpenAI is building custom chips, every large company is building custom chips, or they're going to use third-party ones that are being developed. So, the baton of Moore's Law keeps getting handed off from one company to another, and that should give you confidence that the computational rails that we've been on for 130 years are likely to continue.
Did you want to double down on analog AI chips? I know you briefly mentioned.
Sure, yeah. There's only one dot on this right now, but there's another one in development that would be at the top right corner, of course, that if you wonder what's next in silicon, right, other than lithography nodes getting off of light and moving to particles to go another 10x in just traditional lithography, that's one vector. Another is better architectures. And if you look at our brain at about 100 watts, it really outperforms anything we've done with digital computation. And one of the reasons is it's analog and massively connected and three-dimensional. So all three of those vectors, I think, will come. How can we go analog, massively interconnected, which is a wiring challenge, not a compute challenge, and three-dimensional. And one of the ways you can do that is through analog compute. And so this, again, is recapitulating the biological evolution, if you will, of our own cortex. As an example, this company, Mythic, can implement the multiply and add that you have in neural nets. You do them over and over and over again. Just multiply a number in a matrix and add, multiply and add. They can do an 8-bit multiply and add in a single transistor. So for the non-double E's in here, you might imagine that's kind of weird. A transistor is just an on-off gate, but if it's in the analog domain with a flash memory cell, you can actually make a full neural net computer in a standard flash memory array. And that's what they've done for like 100x performance advantage over machines that cost millions of times more. So there are vectors that are going, both digital and analog, that I think will carry this ball forward.
So I know you're on your 4th fund. Congratulations, you raised it recently. How do you invest in AI? A lot of people, know that this is a moment. Is it fish in a barrel, and whatever you invest in, it's going to work? Is a lot of this stuff going to be pets.com? What's your thesis? What's your advice to others? And just because he gives it now, he may be telling you, like, hiding books in the library. Maybe he doesn't want you to do these things, but give a guy a bone. What do you think?
I'm by no means holding back. We've generally, by the way, just specifically to address the hypothesis of the question, we have not found it as useful to try to be secretive about what we're doing, right? Instead, we try to be very open, proclaim on panels and blog posts and social media, which I'm addicted to and post almost every day, openly. What are we looking for? What are we investing in? Everything. We haven't kept any investment secret, if you will. So a quick recap is that when we started in this area around 2012, 2013, the wake-up call was like, whoa, the GPU. Well, GPUs are done, so we're not going to invest in another one of those. So we invested in Nirvana, which got acquired by Intel. It was the first digital chip that was trying to do AI and did. That was actually here at Stanford Conference 2014 that I first talked about that with Naveen Rao and Ilya Stutzkever. And then we invested in the analog AI one, which you mentioned. And then we were looking for, okay, what is the landscape? And it felt like there was a number of things that still needed to be done. One was architectures for improving how AI works. So companies like Mosaic, which became part of Databricks, and also the whole another branch of edge AI. How can we bring these neural networks into everything, every security camera, every car, every physical device? Imagine you could speak with a voice interface to your Roomba and it would do what you want for less cost than the plastic buttons on the interface today, right? Wouldn't that be a better future? And so edge AI was one of those investments. I see Jags here from Latent AI. He's speaking in the afternoon on that topic. I think there's a whole panel on edge AI. But just when you think about AI, there's transformers and the big models today, but there's the entire enormous opportunity. It hasn't even started really, other than the military, for where you can use AI in drones and in cameras and everything. So imagine autonomous cars is a great example. Humanoid robots will be another. So we've invested in a lot of those things. We've also invested in some vertical applications. Our most recent investment, for example, is using generative AI to do analog chip design. So kind of coming back full circle, how can we generate more creative solutions in the idea space of analog chips? As well as we're on the constant lookout for new ones in the fields of healthcare and what have you, medical imaging.
So you just mentioned edge.
Yeah.
Edge AI, super long context windows, agency, and AGI. What advances are yet to come for AI that you think are like mythical, or a distraction, or do you think are real and around the corner?
Well, I think there's a lot. So in addition to edge AI, so imagine anything that feels magical in the next 10 years is probably due to AI, right? So your car driving itself used to feel magical until the Overton window shifts, and it's like, oh yeah, of course the car drives itself. Well, that's
define the Overton window.
This idea of like what we consider normal. Right, like, and anything that gets shipped in AI, it's remarkable how quickly we acclimate and be like, oh yeah, of course I can talk to a machine and have an intelligent conversation.
Combustion engines originally had a guy with a handkerchief walking in front of them to pull something down a barge, and they only went 5 miles an hour. It wasn't normal, and now we have, it's a little different.
Take it for granted, right? So there'll be the whole edge AI. I think everything that moves in the military will be intelligent, right? Every shell, every missile system, that entire field is going to completely transform. Same is true for all automation, for all moving vehicles. Everything that moves will be fully autonomous, from planes, trains, and automobiles to ships, you name it, within 10 years easily in terms of the architecture of the next generation. It takes a while to roll out the old stuff. So that's one.
Yeah.
Then there's, the whole field of agentic and AGI is coming, and then I guess what was another one you asked me about?
I said super long context window,
So
agency,
here's one little small thing that the transformers are going to do in the near future, because the current XAI and OpenAI and what have you is you may not be aware of this if you type in a query, because you typically don't type in any kind of query or chat exchange that's voluminous, right? Unless you're attaching files. But if you're in the habit of attaching files, the question is how big can they go? And they don't scale that well today. So most of the transformers, in fact all of them, scale with an n squared with the context window, meaning your prompt size. So there becomes a computational expense that grows and very painfully if you try to insert larger context windows. So there are ways around that, and there's some very interesting research going on specifically to solve this problem. If you solve this problem, where you could dump, I'll give you an example, the entire English-speaking Wikipedia into your prompt, like given this, answer a question. Or given all news written by all sources in the last 3 months, just given recent news, answer a question about recent news, right? So you give the context, if you will, could be an enormous bolus of information. What that could open up is, of course, personalized search, news search, what have you, but also any business, any small business that wants a AI for their business wouldn't have to retrain a neural network. In other words, there wouldn't be any retraining. It wouldn't be like a custom version of the neural net or the AI. It would just be a really long context window, which is everything, like Reid Hoffman, everything he's ever written, every book, every blog post, everything, comma, how would I answer this question, right?
So if Wikipedia never happened, how would the world be different right now?
If it never happened? Well, there's other data sources. I mean, it's a really interesting question.
I know, but the fact that that's organized like it is, would we be in a different place right now?
You mean in AI?
Yeah.
Well, it is definitely a training corpus. It has its own biases, but Reddit and other human dialogues is more up to date. Yeah. So one of the things in AI that led us to invest in XAI, that was, by the way, one of our most recent, maybe a year ago, was this idea that there's a data flywheel in AI, and data poverty is the issue. It's the biggest issue in robotics. And
the winters happened was because we didn't have the data.
Where do you get it? Right. And once you crawled the entire internet, where do you get?
You mentioned XAI twice. I know you were on the board of Tesla and SpaceX. I am going to ask you to tell us something about Elon that people don't know. Whatever. But do you just invest in him because you're buddies, or do you do due diligence? And then, what is XAI? Is it one of your loss leaders? You're like, we'll see where it goes, or are you believing in it?
That's a great question. Oh my lordy! So we have invested in everything.
But you're not. You aren't going to come back and tell us something we don't know about Elon.
Maybe, maybe. I'll have to think of something because I don't know what you don't know. But I'll try.
Dig deep.
Okay, so we have invested in everything including my prior firm, everything that he's done this century.
You debate it, or you just do it?
Both. It was activated.
Really?
Yeah, I'll give you an example. The one and only time in my prior firm that I was shot down by my partnership, having advocated an investment, like actually going to the mat and saying we should invest in company XYZ, and the vote went against me, which is weird, that only happened once, was for SpaceX. Mm-hmm. I literally got shut down. And I couldn't see any way that it could be more than a 3x return on investment. And I didn't take that no for an answer. I instead
didn't anticipate NASA needing.
No, well, there was a lot of things went in our favor, definitely. But at the time, it was like, no, this was not obvious. It was only when there's success do you look back and say, oh, that was a brilliant investment, right? So, for example, in the case of Tesla, every prior startup in the automotive sector, writ large, had gone bankrupt for 50 years. Makes it tough to do the next one, right? The road was littered literally with the remains of those prior companies. So no, we did get shut down. We do have discussions. We do also think he's the most remarkable entrepreneur that the world's ever seen, and probably the greatest hit of the American dream as an immigrant coming to the U.S. So in many ways, I can't say enough positive about it. I've known him for 30 years.
It's complicated.
Yeah, he wears his heart on his sleeve, and unfortunately tells the whole world about it at every given moment. So you get more visibility there than anyone else, and that has its own ups and downs. But
all right, I'll take that as the thing we don't know.
Yep.
You get a pat. Yeah. Okay. All right. What advances are yet to come for AI? You just talked about that. What gives you confidence that AGI is possible?
Yeah. So I mentioned that.
And has it happened already?
Well, gosh, right? Yeah. And where, if so? There's all kinds of funny answers to that question, possibly. But one of the reasons I'm confident that we can get to AI as defined in AGI, like in other words, something comparable to human intelligence and then vastly exceeding it. It's not just Ray Kurzweil's Moore's Law that gives us the computation will get us there. If we couldn't get there, if there was some ultimate, if you will, asymptote to humanity's capacity to compute, you might argue, hey, we're not going to recapitulate the brain because we just never get there. So you can remove that argument against possibility space. And then once you do that, it really it takes a relatively small leap of faith, I think, to think that an evolutionary algorithm, broadly defined, iterative algorithm of improvement like we have with neural networks, couldn't produce an AI. And as a thought experiment, you could ask yourself, well, what makes me think we're the endpoint of evolution? What makes us think that humanity is the end of it all? We have a very slow biological evolutionary process, but if you look back in time, we've continually improved in intelligence over quite some time, especially with the frontal cortex. And we would expect over millions of years of biological evolution, we would have smarter, more capable humans than we have today. That would just be normal. It would be weird to argue, oh, no, that all ends at some point. And so when we're recapitulating that vector in biology, there's all these, and sort of in silicon, there's all these fascinating analogs between our biological evolution and our fetal development and what happens in AIs when we train them. It's remarkably similar. The way that there's this subsumption of low-level, almost like sensory cortex-like functions in image recognition, and then higher-level precepts, and it's so similar, it's spooky, that it gives me confidence, and that's from the 80s to today, that this is the better vector of getting there. So, for example, if you said, I'm going to do rules-based, or some sort of ancient form of AI development that didn't pan out, you could actively debate, how would a human ever engineer and design something that exceeds human intelligence? How is that even possible? Why would we imagine that leap of faith is possible? If you instead say, how can I build an iterative learning loop, let's say with reinforcement learning or something else, it wouldn't surpass us in chess, surpass us in Go, surpass us in just about any activity where you can have a feedback loop, it'd be hard to argue against that. So that's what ultimately gives me confidence, and also in focusing on those vectors of improvement. Where can we, like within, for example, circuit design, mathematics, coding, there's very easy ways, easier relatively speaking, ways to verify a design. You can iterate more quickly, and that's where AI shines earliest.
Yep.
And then over time, I think we'll get there by recapitulating the subsystems of the brain.
Yep. So let me ask you this. I taught a course in college, Star Trek: The Contemporary Epic. Love Star Trek. The way they hopped around, they got really far fast. It doesn't seem like we have faster than light travel anytime soon. So I'm a little upset that I don't feel like we're on track. Going to space, this is entitled a space thing, and we haven't even talked about space. Sure. What's next in space? When will we go to Mars? Why would that make value? And then, our boots on the ground right now that are going to land on Mars. And then I've been hearing from really smart people that I respect that AI is going to find life in our solar system much faster than anyone anticipated. I've been hearing that from a few different sources. Is that like conspiracy theory stuff, or is that real? Just riff on space stuff.
Well, I think that's just a guess. I would be more willing to bet AI will find signs of life in other solar systems than in our own. In other words, there's currently living. But we can come back to that. So first off, Mars, sometime in the next 10 years, we're going to be doing landing parties. There's some fuzziness, but it's not hundreds of years. It's, within 10.
Did you buy any tickets to go to?
No, I'm not going to go. I want to do
a
lunar low, very low orbit lunar vacation, but not a settlement on Mars. So the first landing parties will be humanoid robots, which is kind of an interesting development of late, if you think about it. It's sort of obvious now in retrospect that you want to prepare the environment with the greenhouses and everything else for the eventual humans that will go there. The reason to go to Mars is a permanent settlement of humanity, have an outpost, make humanity a multiplanetary species. The moon isn't quite as robust for that. There isn't very much carbon on the moon. Mars is a place you could imagine humanity one day flourishing without a supply line coming from Earth. You mentioned Star Trek. The speed of light fundamentally, I think, dictates many of the AI features in space. So speed of light, AI features. One is latency to Mars. As we know with the rovers, it is just a pain in the ass and incredibly slow to do teleoperation. You have this, inviolate rule that it takes time for signals to come back and forth. So you're going to have autonomy. You need robots on Mars. That's sort of like the obvious. AI and robotics will have a huge application there. The second, much more far-looking, is other solar systems. I would make them somewhat more provocative statement that I don't think exploration of other solar systems is for humanity. I think it's for our consciousness, our future intelligences, but it's going to be robotic landing parties, or at most sending the seed that will reinstantiate living creatures at.
All right, you mentioned consciousness.
But we won't send it in because of speed of light.
Yep.
Because that either this was the game designer of our simulation was like, we don't want you going there, therefore we had the speed of light. Yep. But until we discover wormholes or some other way to do faster than light travel, we fundamentally won't be sending physical humans from here to other solar systems.
Yeah. So for some, we may get weird right now. I just want to let you know. This is called imagination action. It's not innovation in action. It's not invention in action. It's imagination action. I know you and Genevieve have been advocates for mental health. I think to use our imagination, we need to stretch our imagination. This is not an area I know anything about, but how are you imaginative? How do you think our society needs to be imaginative right now when we have all these tools? We're not going to be couch potatoes to these tools. We're going to coexist. And in terms of some of the stuff that you care about that I know nothing about, is there anything you want to say that people will listen to the end of this video to hear?
You may have to re-ask that question.
But you see where I'm going?
Guessing, well, sort of. I think...
Is that a good question? All right.
Okay. Okay. I do think.
I mean,
yes.
people may not know what I'm going to, but I do think we need our imagination right now, and some of the stuff you're doing in parallel to your successful.
You mean on the philanthropy side?
Yeah.
Okay. Which is in psychedelic medicine. So maybe.
But I know nothing about it, so I didn't even want to talk about it because I get it wrong. But does that play a role in imagination?
It can. Right. So first, stepping out, imagination writ large. I think creativity is the fountainhead of human endeavor, right? This is what creates progress. This is what allows us to move forward. If you look back in history, it wasn't so obvious that innovation drives human flourishing, but it's pretty obvious today. If you think about the alternative, which is stasis and retrograde kinds of things, having a creative fountainhead of new ideas is essential. I try to nurture that with a childlike mind. Literally playing with children, which I love at home, or just acting very childish at work, as my colleagues can attest. I do think when you're...
And your work is awesome with all the space artifacts.
Exactly.
The whole Estonian has nothing on you. I mean, it's really special.
No, they do. But we do have a fun office full of space artifacts and sort of provocative thoughts for the mind. So I think when you're gripped by fear, you're not as playful or exploratory. You basically go to what's safe. You don't explore the unknown. So in investing, betting on new ideas, one-of-a-kind ideas, really bizarre and out there ideas requires a certain relaxation of that fear and a exploration and creativity. So my professional life is one of lifelong learning, of always looking for the next great thing. We have a framework at Future Ventures, which is we try to invest in things that are unlike anything we've seen before, yet adjacent to where you've been. So think about these as like frontiers, of final frontiers, and other frontiers of the unknown. That's where we learn. That's how we have this dynamism in what we do. That imagination, by the way, I think is going to get turbocharged by AI. So one thing I just mentioned as an aside.
AI is good for creatives, and I don't think the memo's gotten out about
No, exactly. I don't think we've even begun to
say something profound on that.
Okay, I'll say something. There we go. That's a prompt. How about that for an easy question on a panel? Just say something profound on X, Y, Z. I think if you look at any new idea, it's a recombination of prior ideas. Almost never does something happen in a vacuum without standing on the shoulder of giants. And you'll see this contemporaneous innovations occurring around the world at the same time, like Edison, Marconi, and Nikola Tesla at the same time, for example, having the same ideas.
Well, Tesla's not a car?
And then now it is. Yeah, but back then it was sort of being dude. So that idea that every idea is in itself a recombination of ideas is very interesting if you let that simple thing sink in. That means the total idea space and ideas, the number of subgroupings you could form grows as 2 to the nth power. So it's called Reed's law. And the number of ideas we have as humanity just keeps growing. It's, I think, the reason we have accelerating change, the reason behind Moore's law, a variety of other things, is that we are now able to recombine ideas like never before. There had been a lot of partitioning of this. First it was guns, germs, and steel, and different nation states had different degrees of ideas and advancement at different times. Then you had academic disciplines that segregate the vernacular of different groups. And when you then add things like the internet, allowing us to communicate like never before, and then AI that can think about possibility space of ideas like never before. And think of it just the simple translation. Think ideas from information science and genetics and what have you being recombined in new ways. So I think one of the high level abstraction, one of the things that AI will allow us to do is to recombine ideas like never before, come up with new inventions like never before, and have an innovative spurt like never before. So I think I'm really excited about that future for imagination and possibility space. Yeah,
great. So I'm totally excited for the future. And my last question, you're a dad, you have twins. How old are they?
Yeah, they're 5.
5. Yeah. As a parent, are you worried about the world they're coming into? How are you preparing for it? It's not, Stanford admissions is across the way. You got in here on that nice essay about your dad and Steve Jobs. Your twins are going to be using AIs. Who knows? Maybe they'd be uploaded into the cloud, and that's how they're going to go visit Alpha Centauri. How are you preparing them for that? What advice do you have for a dad here, and a mom, and a kid?
Sadly, I don't have a good answer for that one yet. I do think a lifelong curiosity is essential in that if you think of the distant future, the idea that there'll be some thing you've memorized that is static and is a source of a career will probably go away, right? We won't drive for a living. Like 20% of global employment roughly is driving a vehicle. We won't, have to do, repetitive work. The aspect of medicine that will matter will be nursing, because all information will be available at your fingertips. And why are you standing?
Because we're done. I got to get ready for the next panel. Yeah, sorry.
Okay. Yeah. And so it's more of a process than product. So just like in AI, I think the locus of learning shifts to how we create artifacts, not the artifacts of creation. The same analog is like parenting. I think growing in AI is like growing a teenager. You can't modify the thing you've grown, the best you can do is learn how to be a better parent or be a better programmer to usher in the next generation. There's all kinds of implications of that in AI, but when it comes to parenting, I think it's one of being open-minded to that process and trying to focus on that looks learning, not, oh, here's what the thing they need to learn, here's the thing they need to be.
Yep.